Hi everyone. So today we will discuss the one of the important question from linked list, which is how to reverse a linked list. So what is the linked list? Linked list is nothing but a node which consists of the nodes in which every node a hash pointer of the next node. For example, let's say here you can see 1, 2, 3, 4, 5. Here, first node is your head node, and you can traverse the list from first node to the last node by moving the pointer to the next every time. Now the question is you need to do the reverse of the linked list. So reverse of the linked list means your first node will become last node will become the first node. So here reverse of this will be 5, 4, 3, 2, and 1. All right. Now in this question, we will discuss two approach. One is your iterative solution. Second is your recursive solution. So in this video, we will focus only on the iterative approach. In my next video, I will cover about the recursive approach. Okay. So what is iterative approach? Iterative approach means no need to call the same function again and again. That's why we are calling it as the iterative approach. Now, what is the first thing which is coming to your mind? Okay, just try to solve the problem by yourself. Pause the video for some time and try to think what is the first thing which is coming to your mind, how we can do the reverse of the linked list. So the first thing actually, which is very important is whenever we will talk about the reverse of a linked list, the first thing which comes to my mind is I can use the stack data structure. Because in a stack data structure, it follow the property first in, last out, or last in, first out. Okay, so which will help us to do the reverse of array, reverse of a string, reverse of linked list. So here, if you will insert all the elements, okay, here if you will insert all the elements into the stack, okay, this way. So 1, 2, 3, 4, 5. If after inserting all the elements into the stack, you need to pop those elements one by one. All right. So once you will pop the elements one by one, you will get the reverse of the linked list. How? So first of all, you will pop the 5, insert 5 into the first node, then 4, insert 4 into the second node, then 3, then 2, then 1. So we got 5, 4, 3, 2, and 1. Right? Yes. Now, what is the problem with this approach? There is no problem with this approach, but interviewer will ask you these two things. He can ask, hey, instead of using stack, can you try to solve the problem in constant memory? Okay, so do not use the extra space which you are using. And second thing, in this approach, what we are doing, we are modifying the data of the existing linked list and we are putting the node value with some new node value. So he can say, hey, don't modify the node value. What you need to do is just modify the pointer. So instead of pointing one node to another, you need to point those nodes to the some other nodes so that you can do the reverse of the linked list. All right, so how to do that? So let us think about this approach. Now it means that we just need to modify the link. Okay, we cannot modify the data. What we can do is we just need to modify the link. So link modification one means what? So if let's say we can do the reverse of each link. Here you can say there is one link from 1 to 2 and there is one more link from 2 to 3 and so on. So what if I reverse each of these link and I will update the last node as head of the linked list? What we will get? So here what I will do, I will modify the so I will just reverse this link from this direction to this direction. Okay, so from 2 to 1. Then again, instead of 2 to 3, we will just do it 3 to 2 and then 4 to 3, then 5 to 4. And last node you need to update as the head of the linked list. So here 5 is nothing but your head of the linked list. All right. And first node you need to update, you need to point it to the null just to make sure that your list will end. If you will not update it, your list will never end, and it will be kind of the keep going, you will keep printing the data always, right? So what we want now, we just want to reverse each link, and we will update the last node as the head of the linked list, and that way we will get the answer. Now, okay, so how to solve this reverse part? So we will just take one by one. Let's say there is one node only. Your list has only one node. It means reverse will also be same, because when there is one node, reverse of one will be one. So nothing will change. And in this case, you just need to return the linked list again. Now, when your linked list has two nodes, then we need to write down the logic. Now, very important. Here you need to understand what we can do. So let's say you want to do this pointer, you want to reverse it. Means instead of 1 to 2, you want to move this pointer from 2 to 1. Now what we will do to achieve this thing, we will take 2 pointers, 3 pointers. One is previous, one is current, one is next. I will explain you the use of each pointer. Don't worry about that. Now this node, so this node will be your current node, and this node will be your next node. Okay, so here C stands for current and stands for the next node. Now what you want to modify this link from 1 to 2 to 2 to 1. What I can do, I can say that current dot next. Okay, current dot next will not be next now. It will be null. Okay, so this is the thing which I want to do now. Now, if you will modify this one next to the null here, now next part is how you will go to 2 now, because there is no link in between now here, right? How you will go to the second node. That's why we are keeping one pointer called next, just to store the data in the next variable. And after modifying this link from here to here, we can use this next to update our current pointer. So here you can see we are storing the next into the next variable, and then in the last we are putting the next into the current variable. And line number 2 will just do the reverse of the link. So current dot next will not be next, it will be the previous node. And then when you are moving your current to next, that time you need to update your previous also. Now what is the previous? In this case, previous will be null. So current is 1 dot next will be null, which is what we have done, right? Now we are updating previous to the current, which is nothing but your 1. Now once you reach to this part, then you will do current dot next equals to previous. So 2 to next will be 1. All right, so this is how we can achieve the thing. And once we reach to the last point, then we will just update our head node as the previous. Okay, because previous is pointing to the last node, and you need to keep doing this thing until your current becomes null. Let me explain you with the help of one more example. Don't worry. So let's say we have 3 nodes here, 1, 2, and 3. Now you need to define 3 pointers. One is previous, one is your current, one is your next. Now, first of all, your previous will be null. Okay, default value of previous will be null, and you need to initialize your current with the head. So head is nothing but 1. Now, as of now, next will not be anything. In the first line, what you will do, you will update the next value as current dot next. So 1 dot next will be 2. It means next will be 2 now. Now what you will do current dot next equals to previous. So current is 1, 1 dot next will be previous, which is null. So 1 dot next will be null. Then next you will update the previous as current, current is 1, and current will be next is 2. So you will get current as 2. Now you reach to this point. Here previous will be 1, current is 2, and next will be 3. How we are getting 3? From the first step. Second, you need to do again current dot next equals to previous. So 2 dot next will be 1. This is done. Update the previous to the current. Previous will be 2 now. Current will be 3 now, which is next. Right? Let us jump to this one. Your previous is 2 now, current is 3. Next will be 3 dot next, which is null. All right, here you can see it is null. So it means that your next will be null and current dot next will be previous. So 3 dot next will be previous is 2. So this is done. You will update the previous as current and current as the next, which will be null. Now, since your current is null now, you need to stop here. And your answer will be your head node will be previous, which is 3. All right. So head will be previous, which is 3. Now, how you will get the answer? From here, what we can say? 3 is pointing to the 2, 2 is pointing to the 1 is pointing to the null. So 3, 2, 1, null. This is our reverse of the linked list. All right. I hope it is clear. Now, the same thing we can do in the programming also. So let me quickly write down the code just to explain you guys. All right. So this is the linked list I have taken 10, 20, 30, 40, 50, 60. Now we just want to do the reverse of the linked list using the iterative method. So what I told you, we will take 3 nodes. Okay. So take 3 nodes. And what are those 3 nodes? One is your previous pointer, which will be null by default, right? Second thing, you need to take current node. Current will be your head of the linked list. So here head is defined into the global, and then you will take one next pointer, and next will not be anything in the static. What we need to do, we will just run a loop until your current is not equals to null. You will keep running the loop until your current is not null. Now there are 4 steps I told you. First step is you need to store the next variable. 1 second. So first of all, you will take the next variable. So next will be current dot next. It means we got the next into the next variable, and what you will do, we will do the reverse of the pointer. So current dot next will be our previous node, right? Then you will update these to pointer. Previous will be current, and your current will be next only, right? In the last, what you need to do, you need to update your head node with the previous node, and we got the answer, right? We can print the linked list just to get that are we getting the answer or not. So let me quickly run it, right? We got 60, 50, 40, 30, 20, and 10. So very simple code. These 5 to 6 lines will solve our problem, and we got the answer. So if you want, feel free to take a screenshot. I will put the same piece of code into the first comment of the video. And thank you everyone. If you like my content, please like, share, subscribe.